Hi everybody, welcome to another video in College Algebra, section 2.1, Basic of Functions and Their Graphs. 1. Relation and functions. First we define a relation. A relation is any set of ordered pairs. The pairs of numbers that have order. The set of the first components of the pairs is the domain. The second component is the range. Here is an example of a relation. We have order pairs 1, 2, 1, 3, 2, 3. It has order, so we cannot interchange the numbers. So we're just going to list everything on the first component of the order pairs as a domain. So we say domain one. We have 2, 1. So we say that 1, 2, 3, and 4. Just need to list number ones. And the range is the set of second component we have 2, 3, 5, and 4. Doesn't have to be in the order, in the right order, but order of number doesn't matter. We're just going to list all of them. Right, so that is a relation. Next we define a function. A function is a correspondence from the first set, the domain, to the second set, the range. So it is a relation. However, each element in the domain corresponds to exactly one element in the range. So, because the key part here is each element in the domain corresponds to exactly one element in the range. So let's just write out the relation here as a relation like this. So we have the domain. We already set it here. We have 1, 2, 3, 4. This is the same relation we had before. And then the range 2, 3, 4, 5. Right, now we write the relation 1 to 2. So this is an order pair, so I'm going to write the arrow, because arrow go only that direction and not the other way around. So 1, 2, 1, 3, 2, 3, 3, 5, and 4, 4. Right, the arrow only go one way. Right, according to the definition, each element in the domain corresponds to exactly one in the range. There's a problem here. We have one element in the domain, but there's two corresponding to two elements in the range. So because of that, this is not a function, because we have one corresponding to two elements in the range. So the answer to this is no, it's not a function determined. So it's not a function. Because I'm just going to say 1 corresponds to 2 and 2, 3. We cannot have that. So it is not a function. Right, here we have more example. So is this a function? So we have 1 go here, 2 go there, 3 go here. In this case, each element in the domain corresponds to exactly one in the range. Think about this is like the shooting squad or something like that. Each one of this in the domain has one arrow only. They can shoot whatever they want. However, they only have one arrow, So one arrow can only hit one target. So this is perfectly fine because those two guys decide to shoot at the same target, which is okay. What is not okay is because each one of them has exactly one arrow, they cannot shoot two targets. Because of that, this is not a function. Because one element in the domain corresponds to two in the range. This one, each one of them has one arrow and shoot at one target, so this one is a function. Right, next. Given x squared plus y squared equal to 2 is y a function of x. So in this case, we just simply solve for y like we did before. I will subtract subtract x squared on both sides. So we have y squared equal to 2 minus x squared. And to get back to y, because here we have y a function of x, we just solve for y in terms of x. I'll take the square root on both sides. And one thing we have to remember from section 1.6, every time we take the square root on both sides, we have to put plus or minus. So with that, we have y equal to plus or minus square root of 2 minus x squared. So is y a function of x? Think about it this way. If we have one x values, we will have two corresponding y values, one corresponding to 2 minus x squared, one corresponding to negative 2 minus x squared. So we have one x values may corresponding to two y values. So this is not a function. So y is not a function of x. I should write like that, but because one x value gives us two different y values, so it's not. Same thing here. Given x squared minus y equal to 1 is y a function of x. So to solve for y, just go ahead and plus y on both sides. And then minus 1 to minus 1. So we have x squared minus 1 equal to y. So we have y equal to x squared minus 1. So here only have one x values, it was one y values. So in that case, y is a function of x because we have one x values. For every x values, we can only have one y values. So yes, so we say y equal to x squared minus 1. So y is a function of x. Right. So simple enough. Next, if we have a graph and we determine we want to know if it is a graph of a function or not, we can use the vertical line test. The theorem says if there is a line intersect a graph more than one point, at more than one point, then the graph does not represent a function. Right. So it is defined in the negative term, meaning that it does not represent a function. So we say the graph represents a function, or we can write that in the different way. The graph represents a function if there is no vertical line cut the graph more than one point. But we don't want to define something in the negative, like term, like we say the graph represents the function. If there's no something happen, that usually it's not as good. So we can say the graph represents the function if on the vertical line intersect the graph at most one point. Right. For example, the first graph, we just draw a vertical line. If you see on the vertical line cut the graph exactly 1 point, no more than 1 point. So in that case, it is a function. We'll do the same thing. If we draw the vertical line, and if the line cut the graph more than 1 point, in that case, it is not a function. And same thing here. That's a vertical line, and this is also not a function. Right. Next, we have graphs of function. Some characteristic of graph of a function. Definition: the x-intercept. X-intercept is the intersection of the graph with the x-axis. So x-intercept intersect with the x-axis. The graph intersect the x-axis. If it is on the x-axis, it will have the form of something, comma 0. Of this form, that is the x-intercept. Likewise, the y-intercept is the intersection of the graph with the y-axis, and it is in the form of y. 0 something y, meaning there's something here, could be 0, could be something, but the x coordinate must be 0. And we define the 0 of the function is a value c such that it is equal to 0. So the values of the function, the 0 of the function will make the function equal to 0 when we substitute into the variable of the function. Right. Now we are given graphs and we'll determine the following information. So first, determine the domain and range. Just make things more clear and more interesting. I'll make the graph here is a solid dot and make here an empty circle. Right. Now, the domain. The domain is all the x values or the first component. By default, the x is the horizontal axis, the y is the y-axis, is the vertical axis. So the x values is on the horizontal axis, the y values on the vertical axis, and also the domain is the first component, therefore the x values. So I will say it here. Domain is the x values, and the range is the y values. And this is by default we have y equal to f of x. Y is a function of x, then this is the case. Right, the domain, the x values. So here we have the x values from 1 to 4, but not including the 4. So we're going to use parentheses at 4, bracket at 1, and this is the domain. So we're going to write from 1 to 4, not including the 4. Right, the range. The range will go from here to here. It certainly has the point here, so that is the bracket. even though we're missing a point at 0, but there's a point at missing a point at 4, but there's a point at 4 here. So just go from 1 to there, and by default, if we don't have an empty circle, it is understood to be a solid point. So we just have from 1 to 5 as the range. Right. Next, the same thing. Actually, different things. We have the graph. Find the following. The 0. The 0 is the intersection with the x-axis. So we have two zeros here. We say x equal to 1 and x equal to 4, because when we put 1 into the function, the y value is equal to 0, and when we put 4 into the function, it is also equal to 0 because it is on the x-axis. So the 0, we say x equal to something as a 0. However, for the x-intercept, which is when y, the intersection with the x-axis, because of that, we have the form something 0. Y x can be at something, but y is equal to 0. Intersection with x-axis, meaning y equal to 0. Right. So in that form. So here we have two intersections with x-axis at this point and that point. But for the x-intercept, we're going to write as a point. X equal to 1, y equal to 0. It is a point. And x equal to 4, y equal to 0. Y-intercept. Y-intercept is the intersection with the y-axis. Meaning x is equal to 0, and we look for the form x equal to 0 and y equal to something. So the y-intercept is where x equal to 0 and intercept with the x-axis. So this is the y-intercept. So 0 is the y-intercept. At 0 for the x values, the x-axis, the x value, sorry, and 4 on the y values. And this is the y-intercept. X equal to 0, y can be equal to the y values. That's intersection of the y axis and the graph. Right. Next, determine the range, domain, x-intercept, and y-intercept for this graph. So first, the domain. The domain, all the x values. You see, all the x values go from here, and then from that point, just keep going on. The arrow meaning it keeps extended forever. So in that case, what we see is domain, all the x values here, and then from there continue indefinitely. So we just go from negative infinity to infinity, even though this is an empty circle here, but we go up to that point, and then the circle. So there's a point, certainly the point at negative 1. The arrow point this way, meaning to go indefinitely to the negative infinity, and this arrow meaning to go to positive infinity. So that's what we have here. The range is a little more interesting. The range all the y values, right? So first we have the y values of negative 2. All of those lines only have one y values, to we just say isolated -2, and then all the y values go from here, from the lowest point, go to indefinitely, because there's an arrow. Keep going, and by default it doesn't have an empty circle, so it's a solid dot. So this is union width from -1 to infinity. So -1 to infinity, and then this is just -2 upon just a single values. Right, so that is the domain of range. The x-axis, I mean x-intercept, x-intercept is when y equal to 0, or intersection with x-axis. So we see here one point here and one point there, and since y equal to 0, we have the point 0, y equal to 0, and y equal to x equal to 4, y equal to 0. So we have two x-intercept, and y-intercept we cannot have more than one intercept, because if we have two y-intercept, it fails the vertical line test. It cannot be a function, right? If there's 2 points and the graph go like this, the vertical line will cut the graph at 2 points, so it's not possible. So we might have many x-intercept, but we can only have at most one y-intercept. So in this case, y-intercept, of course, is also that point. So just say it, intersection with y-axis, meaning that x is equal to 0. So we have the point 0, and the y values there is also 0. Right, so we identify domain and range, x-intercept and y-intercept. Right, next we have this graph. So from that point going down. However, the x values, it can go anywhere from this, go on the right side and on the left side, so there's no restriction. So because of that, x can be any values, so we just say -infinity to infinity. The range, it can only take these values from -2 down to infinity. But we write a smaller number first, -infinity up to -2, and by default there's no empty circle, so that is solid dot and including -2. So -2 or -infinity to -2, always smaller number first, bigger number. Right, so that is the domain of range. X-intercept, based on the graph, there's no intersection with the x-axis, so there's no x-intercept. Y-intercept, there's one point here, and y-intercept, the x value is equal to 0, intersection with the y-axis, so x value is equal to 0, just have 0, y is equal to -2. So that is the y-intercept. Alright, so that's all we have for this section. See you in another video in course algebra. Thank you for watching.